Hey everyone, happy to see you all. Who has been at my talk this morning and came back? Wonderful people. Who of you already feels a little bit tired after the whole day of conference? Like it's a little bit tired? Like, I promise I don't try to bore you that much, and I promise that I try to prevent you leaving this room. And my topic that I'm going to speak about will be quite like this, but it's not about people leaving a room, it's about people leaving your application because the performance wasn't good. And I'm trying to be really performant here upstage. So let's see. I introduced this morning, I'm Christian, I'm software engineer at Source Labs. Damn it, I wanted to say, I forgot how it's pronounced, I'm sorry. Exactly, here. Good day, everyone. Yeah, I'm a software engineer at Source Labs. I've been on a product team that has been built a performance tool on the Source Labs platform, and I discovered a lot of things about performance and front-end performance testing, which I would like to share today. And the reason why I think this is a really important topic is that you already have a lot of trouble keeping up with functional accuracy of your applications. Why would you be concerned about performance? That's another thing that you need to think about. But it's kind of important. There's this term called next billion users. Right now, 50% of the human population is on the internet. You and people everywhere in the Western atmosphere. But the next 50% will come on the internet in the next 10 or 20 years. And they will not have an iPhone. They will not have the latest laptops. They will come with things like this on the internet. On the left, you have a Geo phone. That's a feature phone, and it's running on a fork of the former Firefox OS, which is called KaiOS, which runs a Firefox version 42, which is not the latest Firefox, but it allows you to run to surf the web with a really cheap phone that is really easy to produce and really affordable for people in the emerging markets like India. On the right side, you have a Nokia 2. It looks almost like an iPhone already, but it's far away from what an iPhone can do these days. It comes close to what the first version of an iPhone was, from the CPU and the memory-wise. And in the States, these phones are produced for people that live below the poverty line. And that makes almost 16% of the population. And you need to think about if you want to be inclusive for people that come on the internet with these kind of phones that have like a restricted CPU and memory allocation, and they don't have the latest phones. And they want to still surf your web. They want to still use your phones. And people get really angry when the performance of these websites are not really fast enough. There's a study saying 53% of all mobile site visits are abandoned if it takes longer than 3% to load. The average page size was in 2018 3 megabytes. It was 4 in 2019. We'll see what happens this year. And the average page load is around 3.21 seconds, so already quite a lot. And also, Google has their take on that. They say, how fast your website loads is critical but often a completely ignored element in any online business, and that includes search marketing and search engine optimization. That means, your customers that go on your website are being annoyed by the slowness of how your page loads and drop and leave the page immediately. And then Google is like hurting you even more by saying, okay, this page is slow, we're going to put it on the 4th page of the search results. Perf matters. This hashtag perf matters is a movement that has been around for a while, pushed by front-end developers and developers that are invested into the web to make sure that people understand how critical performance is on the web. And they give workshops, they do conferences, they provide tooling and learn materials. And I think in our QA space, we should shift the minds towards being more performance focused and make sure that whatever we ship is going to be fast for the end users. There was this American business guy called Harold S. Geenan. He lived in the 70s in the States. And he said, performance stands out like a ton of diamonds. Non-performance can always be explained away. And he lived in the 70s. He had no idea about performance, no about the web, no about the web development. But this quote fits it really well today. We have already a lot of great tooling around how we detect performance issues, but we don't really leverage it, and we don't really make sure that what we ever ship to production is performant. So let's try to understand what performance is and try to make sure that our apps that we ship to production are performant. In order to do that, we need to understand what performance even means. What does it mean my app loads fast? And to do that, let's look into some metrics that can define the performance of our application. And a good first metric is the time to first byte, which is the time that it takes until you put something in into your browser URL line, and the response comes back from the server. And this metric is pretty critical because if that metric is slow, it can delay all the other metrics that I will talk about in a minute. So it's like if your server is slow in responding, that means that your browser is sitting there doing nothing because it waits on the server to respond, as well as your user is sitting there doing nothing. And that's a horrible experience for the user. Then there's a variety of rendering-related metrics, starting from the first paint, which means that whenever the browser was able to first paint something on the web, that's usually some sort of background or a gradient, whatever you have. A little bit later, there's a first contentful paint, which means whatever once the browser has rendered the HTML, has rendered the CSS, he draws like an image or an input element or a paragraph. And that will be something that is from the DOM, and that we say first contentful paint, which is some content from the DOM is being painted. Then a little bit later is the largest contentful paint, which means whenever something that is really useful for the user, that the user can start to consume, is being rendered on the page. And last but not least, time to interactive, which means when the user can finally start navigating and experiencing the app. There's another interesting metric called speed index, which tries to compute a score that determines the overall speed of how quick the content is being painted. You have here two examples. The optimized page that uses progressive rendering, and the unoptimized page where there's nothing for a while and then everything pops up, which is not a good experience. And speed index is trying to calculate the area, the white area in this graph, and as lower this area is, like as less white you can see, as better it is. So if you have a really small speed index, that means that the page was able to render progressively really well. So we can, put our metrics into three buckets: milestone-based metrics that are, define some time duration; a score-based metrics where I would put speed index to, but some people say that is a milestone metric too. But there's a Lighthouse performance score, for instance, that you can put in that bucket, and resource-based metrics where you say, I don't want to ship more than 250 kilobytes of JavaScript to the user. And you might think yourself, well, those are a lot of metrics. Are all these important? Do I need to test for every one of them? And the answer is kind of yes, because if you say my app loads fast, what does fast mean? Fast does mean for everyone something different. For an e-commerce page, a fast page is when someone can access the search bar to search for a product. But for like a magazine page, it is fast if the customer can read the content of the article. And some people at Google tried to find out and try to define the term fast by answering a couple of questions, starting with, is something happening? Does the browser start navigating, and does the server respond? And as we just learned, we can answer this metric at looking into the time of first byte. Then we ask ourselves, is it useful what the customer is seeing? And we can answer that by looking into time to first paint or time to first contentful paint. Then you can ask, is it usable? Can the user interact with the page, or is it still busy loading? And we can answer that by looking into time to interactive. Last but not least, is the page delightful? Is it really a good experience if I scroll around, if I use and interact with the elements? And we can answer that by looking into the blocking tasks and the long tasks of the browser, which we'll look into a little bit later. And you can kind of compare that when you go into the restaurant with your partner, and you sit on a table, and then you have to wait for an hour until the waiter comes and gives you the menu to ask you what you want to eat. You have to wait 1 hour until you kind of start consuming things. While on the other side, it's much better if you come to a restaurant where you sit down and the waiter immediately brings you water and some snacks like breadsticks or something like that, that you can start snacking while the food is being prepared. This is kind of like a much more nicer experiences where you would always come back. And you can compare that with that. So fast forward to today, we see that the window on load doesn't really reflect the user perception as it did once. So if I say my page is loading fast, it takes 5 seconds to load. It's technically okay that to say, but it doesn't really reflect the user experience and the reality. To understand how the user perceives the page load, we need to understand first how the browser perceives the page load. Anyone knows, or anyone has done that before? Going into the DevTools and doing a performance audit? Some people? And everyone was, like me, confused about what this flame chart all means and what it had to say, and where this data even come from. So I digged a little bit into that, and all this data are called trace events. So whenever you turn on this performance audit, the browser just logs a lot of stuff into the memory and allows you to consume the data afterwards. Those trace events, they have a name, they have a category, they have a specific type. There are duration events where this JavaScript function starts there and this JavaScript function ends there. Then you have instance event, counter events, and variety of events. The trace event format that is defined by Google is pretty sophisticated and long, but it is really, it has a lot of detail, and it is well supported in the Chrome ecosystem. And like any other trace data event, it comes with some arguments. And usually if you take a trace log or you capture some trace logs, you get like a big file of JSON elements, which you cannot really open with your IDE and look into it. You wouldn't get any information out of this. So people build tools around it. Like in the DevTools, we have this little graph that shows us the heap size, the amount of documents, the amount of nodes in the page over time. And this all comes from a trace event, which is an instance event. It's called update counters. It's in the DevTools timeline category. And it has this data that is shown in the graph just as an argument. And just like this, the DevTools application can draw this little graph. Another example that's pretty popular are the screenshots, this film strip that you have, which is in the category disabled by default DevTools screenshots. The name is screenshot, and it has a base 64 100 times 100 pixel screenshot image. It's prefixed with disabled by default because some categories have some performance impact if you turn them on. You have to be careful about that, but usually, especially screenshots, this impact is really low. So there, you can display these data and help users make sense of it. And the Chrome team did a really great job building a tool called Google Lighthouse, which takes all these data and creates a variety of metrics out of it. Like all the metrics that I've described with the film strip, and gives you a lot of information about how you can improve the performance of your application. Another really great service is the WebPageTest.org website. It does the same. It loads the page and turns on the tracing, and you get tons of information about what is going on the network level, which events are blocking, which requests are slow. And these tools are really great for development. It is really hard to move them into a CI/CD environment and be like, I want to test that. I want to test these metrics. It's also problematic that I can only open a page and see what I get. I want to go to a checkout and see if the third page that I'm visiting has a bad performance. And like I said, it's really difficult to put them into a CI/CD system. So I looked into how can we do this a little bit better as QA folks. And I thought, well, WebDriver already automates the browser in a really good way. So why not just connect Lighthouse and WebDriver in some way to do this performance testing in a more efficient and a more interactive way. I'm maintaining the WebDriver project, and I explained a little bit about that this morning. What I can say today here is that this project allows you to run tests using JavaScript, and it comes with a variety of plugins. And one of the plugins is the DevTools plugin that allows you to hook into the Chrome browser using a separate connection. And with that, I have the ability to do all this tracing and do all the things that I need to pretty much get these performance information out of Chrome. And I have a little demo for that prepared. So I have a demo page. This is called Tony's Favorite Food. It's a small React application that shows the food of my cat, I guess. And I can modify this app interactively using the glitch platform. So right now, this app is perfect. It's super fast. And my tests for that look like this. So I have two tests. I hope I make this big enough. I have two tests. I wanted to test two things. First off, the config shows that I have the DevTools service somewhere. OK, local. So I want to start my test session with my DevTools service and my Chrome driver. So Chrome driver starts automatically. I don't need to care about that. And the DevTools service gives me the ability to do these nice performance things. And my tests look like this. So the DevTools service gives me about a couple of commands in addition to my WebDriver commands, which are, one is enable performance audits, and then the other one is get metrics and get performance score. So what I do here is I open my website, and then I try to get some metrics and the performance score, and I do some research on them separately. These are looking into the first meaningful paint, into first interactive, and the speed index, which are good general metrics to look at. And the resource test does the same, but it turns off all the throttling because that's not important for resource testing. But it does pretty much the same, going to the URL, and then it tries to get the page rate, so I can see how much JavaScript and how much images has been transferred to the page. So, I mean, I can run this test again just to prove that it's passing. So there are two browsers spinning up. One is running the resource test, and the other one is running the performance test with a little bit lower CPU and network rate. And with a little bit luck, one is already flaky, see? Anyway, we forgot about that. Move forward. And now I want to introduce some performance problems in my application. So it's a React application. And what I can do here is to change the Webpack mode from production to development so that my assets aren't minified. What I can also do is I can start mining Bitcoin because everyone wants to get into this crypto space. What this Bitcoin function is doing is pretty much it runs a loop for 3.5 seconds, and it blocks the main thread. We have only one thread in the browser, and if we do something for 3.5 seconds, nothing else can be done. And so this function pretty much represents a really bad JavaScript function. And with a little bit of luck, this application has been deployed. You see it, there's 3.5 seconds where there's just a white screen. And we rerun this test. And it should fail now because I have a little bit more, I sent a little bit more JavaScript to the page, and B, there was this nasty JavaScript function that has caused the page to load slow. So we can see here, the time for first meaningful paint was 6.6 seconds instead of 3. And the overall Lighthouse performance score was 0.53 seconds instead of the expected 0.92%. The same for the resource test. Here, I shipped more than I expected overall, which is caused by the scripts that were more than expected. Images were fine. I didn't do anything with the images, but scripts were definitely heavier than before. So this you can do already open source, and you can download WebDriver and do these performance tests in your pipeline. There are some caveats to this, though, which makes performance testing a little bit more tricky than user functional testing. Because performance testing requires to run the test always in the same environment. You cannot have one performance test run on a slow machine and then the next one on a supercomputer. This will give different results. It's important that the environment where you run your test in is as close as possible, always the same. Which is why this kind of solution that I just showed can work, but can introduce, if your CI environment is not really stable and does not always have the same, if your workers don't have always the same CPU, could be difficult. Which is why I said, let's implement those kind of features into the SaaS platform. So when you run tests on SLAs, SaaS labs, you get a lot of browsers at your hand, and if you run this test, you get screenshots, videos, and since last year, some performance reports that you can use to assert the performance. And it's different at SaaS because we run the VM, it's always in the same state. It always has the same performance, the same power that you run your test in. So let's look into performance testing on a higher scale using SaaS labs. The reason why we wanted to do that and why we are interested and invested in this topic is that we want to shift testing to the left. That means that we want to have you do more tests right before you ship it down the pipeline. Do performance tests on every commit or do performance tests on every merge to see when you introduced a performance problem. And if you look into the performance or tooling landscape, we still have Lighthouse and Chrome DevTools as great tools that you can use for diagnosing performance problems and see where you can improve them. We have also good tools like SpeedCurve and New Relic that help you to monitor performance in production. But there's nothing really that helps you to run performance tests in the CI/CD before you ship an application. And in order to make it really, really simple, we created something called Speedo. Speedo is an open source tool that you can download via NPM or Docker. And you don't need to know anything about Selenium or WebDriver, or you don't need to know anything about performance. You can just run this, and it will run the test on SaaS labs and will assert it automatically. What will happen if you run a performance test on SaaS labs is that we store this data every time that you run the test, and we exactly know by creating a baseline how your performance usually is like. Your time to first paint or your page load, we expect it always to be within 4 or 5 seconds. If you are within this range, then everything is fine. But if we see something behaving weird, then we can tell you something is wrong. And this is what Speedo is doing. You can install it using npm install -g Speedo. If you don't have an account in SaaS Labs, don't worry, just create a free trial account. For 14 days, you can try it out for free. And it does a lot of things. It creates a job at SaaS Labs. It creates a baseline for you if you don't have one. And then it creates a performance test and asserts it against the baseline. And if you keep your name of your test the same, it will always compare with the last results. And you can choose which metrics you want to assert. And it automatically sets your test up to run the Chrome browser, which is currently the only platform where we support this, to run in a mobile-like environment. So we change the user agent, we change the CPU and the memory of the browser so that it feels like a mobile device. We're working on providing this on actual real devices, but this will take a little bit more time. And I think I have a demo for this. Yes. So I was running this Speedo test right before. You can see on the top that I was running it on my magnificent garbage glitch app. I named my test Selenium Camp Demo. And you can see it created a baseline for me, calling Selenium Camp Demo. Then it ran the performance test, it waited for the job to finish, it downloaded all the assets that you need to inspect while tests have been failing. So you can drag and drop the trace logs into your DevTools and see why something was slower than before. And it's currently by default asserts the Lighthouse performance score, which is a general good metric to start with. But you can always, jump on other metrics if these are important to you too. And then again, we throttled the network on good 3G, which is, emulate a mobile device. You can also say, I don't want to have any throttling at all. And we provide you with a job, with the dashboard and with the Lighthouse performance score. So as you remember, I slowed down and made my app a little bit worse, and I introduced some performance bottlenecks. So what I just do, I'm gonna run this test again. And let's see how long this takes. So this time it doesn't need to create a baseline because we already have run this test before. So it just starts running the performance test right away. That should take 1 or 2 seconds. What's cool is that you don't even get a Lighthouse report for free. You always also get the trace logs, which I mentioned before. You can just drag and drop into your DevTools and inspect it over time. Job has finished. We download all the stuff. And there we go. So we are asserting the Lighthouse performance score, which is now 34 instead of 92, I think. So we can just start taking a look on the, OK, this doesn't work. No Lighthouse performance score today, but we can take a look into, oh, I wasn't registered. That's why. I need to log in first. There we go. So there we go. We have the Lighthouse performance score that gives us, for every test, some information about what we can improve and what has been, wrong. It says reduce JavaScript execution time, which makes totally sense because we had this weird function that took 3.5 seconds to run. You can see it gives you the file where this function is located. And then on top of that, we provide you with a performance dashboard where you can see how the performance has changed over time. All these tests before that have been running with the previous Speedo run, everything was fine. Everything was within a decent baseline. And then everything popped up. And every metric almost is now failing. And then, of course, you can look into the trace log to see where something has happened. And if we check this out, if we go down this path, we see the mine Bitcoin function right there. It's a little bit, maybe I can zoom in. No. It wouldn't let me zoom in. But this is the mine Bitcoin function. So it tells me the function where the problem actually happened. But just that would be, people would say this is Lighthouse in the cloud, which kind of makes sense. You have an URL and it would assert the URL. But this wasn't enough, as I mentioned before. We want to do a little bit more. So since we are automating the browser in our VM, we do a little bit more than just starting Chrome driver and running the browser. We have instrumented the browser in a way that we can interfere commands that you send to the browser to do something special around it. That's why performance tests are a little bit slower, because we have to wait until we had all the metrics captured before you can continue visiting another URL. And we don't only capture performance for you open the website, but we also capture performance when you move from one page to another. In this case, I want to test if my Instagram feed is slower, so I log in with my username and password. And then I use Speedo to check if the page load that happened after I submit my credentials has the same speed as before. So for every page transition that happened, we capture the performance of your page. And Speedo's ready for CI/CD. That means you can use the Docker container and just put it into your Jenkins, GitLab, Circle CI pipeline, just as easy. And you can also use, instead of Speedo, you can also use any kind of framework. If you have Selenium currently running in Python or Java, you can use that too. We extended the WebDriver protocol with an extension that allows you to call certain endpoints to test the performance of your application. In WebDriver.io, the example above, since I'm maintaining it, I already provided a command for it. If you don't have that, you can always go the route of using the execute script and use the JavaScript executor, where you just put a script that says source : something. In this case, the command is called performance, and you pass in the arguments. So with that, you can use performance and you can test performance with all the frameworks that you currently use, as long as they support WebDriver. And as I mentioned before, it doesn't only works for a page, opening a page or transitioning to a page. It also works if you have a single page application, like a React application. The difference from page transition is that you can have a soft page transition or a hard page transition. The difference is here for a page like Postmates.com. If you look into the DevTools, you will see that they never load a page. They will be this one app that loads creates a new view, and it never creates a new execution context. That means that you never open a new page. And even for that, we are able to capture the performance from one view to the new to another view, as long as the page history changes. Unfortunately, the GIF doesn't work, but in this case, I do pretty much a checkout on Postmates.com, which is interestingly geo-blocked here in Ukraine when I tried this before the talk for some reason. Anyway, but I was trying to do a checkout flow, would try to order some food, and to see if I can capture all the metrics. And it works even though I don't actually transition to a new page. I'm staying on the same page, but the React application has changed. Before we wrap up, I want to talk a little bit about jankiness, because there's another area besides page loads that is important if it comes to performance and user experience. Does anyone know the term jankiness and what that means? Some people? So, as you know, since the web has changed over the last 15 years, we put more and more stuff on the browser side. These days, nothing gets rendered on the server anymore. The server just sends out the minimal HTML, and then the rest is done by a front-end framework like React or Angular. And this really shows in various of statistics that the browser has to deal with more and more JavaScript these days. And interestingly enough, most of that JavaScript doesn't come from our framework. It comes from third-party libraries like analytics or anything that you put to see how your website looks in production. So Google Analytics, Sentry, marketing tools, Marketo, what you have. Those are the tools that really put some heavy pressure on the browser. And remember, we only have one thread. And most of the things that the browser is doing is running on this one thread. And if something is running longer than 50 milliseconds, then the browser will see some, we call it jank. And jank, by definition, is any stuttering, juddering, or just plain halting that the user sees when the site or app isn't keeping up with the refresh rate. That means if there's a JavaScript function that just runs for too long, then you cannot really interact anymore with the input element. You cannot really scroll anymore. Then elements are not rendered, and your page are pretty much just halted, interacting with it. And we wanted to address this as well. So we created our own way to detect jankiness, and we do that by creating a command that would scroll from the top to the bottom of the page and would do the same for a page load. It would just collect a lot of trace logs and trace events. And we would look into that and try to figure out what's the average FPS, like how many frames per second the browser was able to render. How long was the browser busy with scripting versus just doing nothing? And how much forced reflows did you had in your CSS? If you, change the CSS of an element too often in a wrong way, this can have impact on the performance as well. So if you run this command, we will scroll through your page and try to interact a little bit with it. And then we get all these metrics and create scores for every area. We create a layout update score, a FPS score, a score for idle duration. That means as longer your browser was doing nothing, as better the score is. And we create a memory usage score. That means we look into how much memory your application consumes without using the garbage collector to clean things up. And with that, we created a weighted mean, similar to how the Lighthouse performance score is being created, and give you an overall score that you can use to detect how smooth the website behaves if you interact with it. So to recap a little bit. So today we learned about what performance means and why it is important. We looked into how the browser understands what performance is and what the page load is. Then we found out how we can test it with open source tools as well as on scale using Sauce Labs. And at the end, we learned a little bit about jankiness, which is another area about that is impacting the user performance of your application. Before I end the talk, I want to do a little bit best practices. I know it's a little bit early, and I know from experience that a lot of companies haven't yet started to do performance testing on top of their functional things. But it will be important in the next 2 or 3 years because this performance impact will be bigger and bigger, and people will lose more and more money if they don't pay attention, or companies will lose more and more money if they don't pay attention to performance. So what are some best practices? First off, and this is one of the most important points, is you should separate your functional from your performance test. It's this, if you remember the testing pyramid where you do a lot of unit tests, some integration tests, some small end-to-end tests, and then performance test is pretty much the sprinkle on the ice cake, right? If your functional tests are failing, then you don't need to even start doing performance tests. But if everything is fine, you can do some performance tests for some important pages. When functional, we want to care about being functional accurate across a variety of devices. With performance, that is not yet that important. When browser vendors build their browsers, they have a lot of benchmarking tests that they run to make sure that they don't slow things down with a new release. So if you start your performance test with just Chrome, that will be absolutely fine and gives you already a lot of coverage shipping your applications. And then keep it simple. For you, sometimes it's just enough to test the performance of your main application website, the page that everyone uses to enter your service. If you're a little bit more advanced, you can start having a performance test for a checkout flow or something more advanced. But keep it simple and start experimenting with it to see how much value it gets you. If you run your test on Sauce Labs, we capture the metrics over time by looking into the test name that you use to run your performance test in. And you should always keep that the same. Otherwise, we have to create a new baseline all over again. And it's really important that we understand how your performance is over time so we can make judgments about whether or not something has become worse or better. And then at the end, know what you want to test. For a lot of people, just checking the general Lighthouse performance score of your main application website is simply enough. Sometimes if you're like an e-commerce page, you want to check if the search bar comes first and is really quick, it shows up really quickly. And you would need to look into different metrics if you are in this scenario. But every metric has its own advantage and checks for some other experiences, and you need to figure out by yourself like which experience is most important for my customers. Again, for e-commerce pages, I want to interact with the search bar as quick as possible to find my product. For magazines, I want to be able to see the article as fast as possible. And with that, thank you so much. Any questions? I can repeat the question if you're loud enough.
How does Speedo can refer data get metrics for baseline testing?
So when you use Speedo, you essentially run a test in the Source Labs cloud. So the question was, how can Speedo detect all the metrics and can assert against it? If you run Speedo, you run the test on the Source Labs cloud, and as you can see, you don't see anything, but in our cloud, there's a browser spinning up and doing this performance test. And we capture all these metrics and store them, and we have services and APIs that you can use to assert against it. So Speedo is just leveraging what our platform already provides. You can look into the source code and build something similar that maybe is better for your scenario, but Speedo is generally a good first approach to test performance.
Do you have some sandboxes that need to drive to edge how does it work or something like that?
Yes, so you can start going to the Speedo open source project, and there are some examples how Speedo works, what you need to do to set it up. It's pretty simple. As I mentioned, you download it, and then you say just Speedo run. Make it a little bit bigger. But also, we have also a repository that is called Performance Samples on GitHub, which contains all these things that we're talking about, like the jankiness check. There's a WebDriver example for that, where it would go to this jankiness page that I can show. I'm not sure if you have seen that, but as more Chrome icons you add, you see that it's really slow. And if I optimize it, everything is a little bit better. And this is just the way how you run this animation. You can use some different kind of CSS mechanics to do this animation. And if you use the wrong ones, you get this jankiness effect. And this sample script here uses that to showcase this example of jankiness. But there are a different variety of other examples that you can just check out, create a free trial account and try it out by yourself.
Thank you.
Thank you.